Hey there, in this video we're going to cover average rate of change, section 2.4. So I have an example. Say you travel from Sacramento to San Francisco, and it takes you an hour and 18 minutes to get there. From Sacramento to San Francisco, say it's 90 miles. So what will be your average speed? So that's what we want to know. So what is the average speed? And if you think about we know from other sections that distance equals rate times time, and rate is another word for speed or velocity. So we can say d is equal to s times t, the time, speed times time. So speed is equal to the distance divided by the time. So s is equal to d over t. So the average speed then is the distance divided by the time. So we're going to say average speed is the distance traveled divided by the time elapsed. And so in this case, our distance traveled is 90 miles. And what is the time elapsed? Notice that the time elapsed, we're told, is at 1 hour and 18 minutes. But I can't put miles per, what is it going to be, per hour or miles per minute? So I need to be able to write 1 hour and 18 minutes in either just hours or just minutes. Usually, average speed it's given in miles per hour. So let's try to convert 18 minutes to hours. So I'm going to go over here. So 1 hour, 18 minutes is the same thing as, let's take those 18 minutes and convert them to hours. So 18 minutes, so to convert, we'll do a little dimension analysis. How many minutes are in 1 hour? Right there, 60 minutes. So 60 minutes in 1 hour. And I set it up like this because I want my units to cancel. Minute divided by minute, those cancel. And I'm left with 18 over 60 hours. And 18 over 60, when you put that in a calculator, that gives you 0.3. You can also reduce it and you'll get 3/10, which is 0.3. So that means that 1 hour and 18 minutes is the same thing as saying 1.3 hours. And so putting this on our calculator, we get approximately 69.2 miles per hour. So this will be our average speed. So this is an example of average rate of change. Now, does that mean that you were going 69.2 miles per hour the entire time? No, right? This is an average speed. So when you left Sacramento, going down the surface streets, you're probably traveling anywhere from 25 to 45 miles per hour. Once you got on the freeway, then you're able to travel at higher speeds. You may have been going the speed limit 65, you may be going 70 or 75, and until you get to San Francisco, right? So that's why this is an average speed. It doesn't mean you're always going 69.2 miles per hour. It's just over the time of an hour and 18 minutes, the distance traveled and divided by the time equates to being 69.2. In calculus, you're going to get to talk about instantaneous velocity, which is at a very specific time. But this is average velocity. So average speed or average velocity is a rate of change. So average velocity is the distance traveled. I'm just going to rewrite it again. Distance traveled divided by the time elapsed. So the time that it took to travel. So, for example, if we are able to plot a graph of a distance over time, so if I have the distance here, sorry, hard to write sideways, in miles, and this is your time in hours. And so say you have some sort of curve that describes your travel. So your distance, the distance covered over the time that it took to cover it. And so in general, we're going to say if you travel a certain distance from point A to point B between these times, what will be your average velocity, your average speed? So the average speed is the time that it took to travel, the time elapsed. You're going to divide by this in the distance that it took to travel. So distance divided by time. So this is where you're essentially finding the slope of this line. So you can create a little triangle and find, so the average distance, right? This is your delta y over your delta x or delta t. So the average speed is really still rise over run. So average speed is your change in the y values divided by the change over the x values. So it's the same thing as slope. So you're essentially finding the slope of this line. So if this is a and this is some function f of x, what is this point? This point is going to be a f of a. And if this is b, what is this point? This is going to be the point b f of b. And I'm going to just say here, this is some function f of x. So the average speed, the average rate of change of this graph which when we're talking about distance over time is the average speed, but in general we say the average rate of change is essentially the slope of this line. The change in y over the change in x. So for our particular example, it's going to be, what is it? The formula for slope is y2 minus y1 over x2 minus x1. So for our particular example, it's going to be f of b minus f of a over, I might have my, if this is my x2 and y2, this is my x1 and y1, so I'm doing y2 minus y1 over x2 minus x1, so over b minus a. So this will be our formula for the average rate of change. Notice that the y values, the change in the y values here, as the function changes from a to b, on the y, this is our delta y. This is what is also referred to as the net change of a function. So how much did the y values change? So that's called the net change. So let's try an example. So let's let h of t be the function t squared minus 1. And we want to find the average rate of change from t equals 1 to t equals 3. So that's what we want to do. So let's find that average rate of change. So based on the above, we know that the average rate of change is going to be f of b minus f of a over b minus a. So my function here is called h, so I'm going to say h of b minus h of a, but still over b minus a. So what's my b and what's my a? So going back to that graph, my b is the higher point, the higher time value, and then a is the smaller time value. So here, I'm going to say then that my b is 3 and my a is 1, right? B is the further time value. So our average rate of change is going to be h of 3 minus h of 1, right? H of b minus h of a over b minus a. So over 3 minus 1. So what is that? So h of 3, I'm going to go to my h, and for every, notice that t is being replaced by 3. Everywhere I see a t, we're going to plug in 3. So h of 3 is 3 squared minus 1 minus h of 1. h of 1 is 1 squared minus 1 over 3 minus 1, which is 2. So 3 squared is 9 minus 1 is 8 minus 1 squared minus 1 is 0 all over 2. So I just get 8 over 2, which is 4. So that would be the average rate of change between 1 and 3. Now looking at the graph of this, notice that I gave you a parabola. h of t is t squared minus 1. So what does that look like? So let's graph it. T squared minus 1 is a parabola with vertex at minus 1. And so when we're saying we want the average rate of change of the function from t equals 1, so based on here t equals 1 is 0, so here is 1, 2, 3. So this is not drawn to scale at all, but if I happen to continue this parabola, then we're going to touch somewhere over there, right? When this is 3, what is our y value? So when x is 3, the y value was 8. 3 squared minus 1 was 8. So what we're finding is what is the average rate of change? So you're doing the slope of the line that connects those 2 points essentially. So you're doing the change in y over the change in x. Right? So the rate of change is the slope. Change in y over the change in x. And notice that the change in y is the net change. So net change over the time change. In this case, because t is time. So notice that the net change for this particular problem is 8. So the net change is 8 and the time change was 2. And so that gives us the average rate of change. So think of the average rate of change. You're really finding the slope of a line, the line that connects those 2 points in a graph. So let's try another example. Example 2, let's let, in this case, s of t equals 2t squared minus t. And I want to find the average rate of change from t equals 2 to t equals 5. So find the average rate of change from t equals 2 to t equals 5. So try that on your own. Go ahead and pause the video and try it and see what you get. And then resume to see if you got the right answer. All right, so from before we know the average rate of change is f of b minus f of a over b minus a. And you can adjust it to your particular function, right? So in this case, it's going to be s of b, b is 5, minus s of a is 2, over b minus a. So over 5 minus 2. And so s of 5 minus s of 2, right? This is the change in y. This is what we call the net change. So if you're asked what is the net change, that is just the change in the y values of the function. So that would be the net change. So let's see. S of 5, so plug it into the function. So it's going to be 2 times 5 squared minus 5, right? I'm taking the 5 and plugging it into the t's, minus s of 2. So same thing, take the 2, plug it in for the t, so 2 times 2 squared minus t, so minus 2 again, over 5 minus 2 is 3. And we continue to simplify. So 5 squared is 25 times 2 is 50, minus 5 is 45, minus 2 2 squared is 4 times 2 is 8 minus 2 is 6. So I have 45 minus 6 over 3. 45 minus 6 is 39 over 3. So at this point, you can tell what the net change is going to be. What is the net change? The net change is essentially the numerator of your average rate of change. So the net change is 39, just a change in the y. But the average rate of change then is 39 divided by 3, which is 13. So if we had units here, if this was miles per minute, it would be 39 miles per minute. If it was yards per second, right, yards against second, then this will be yards per second. So it kind of depends on the units. Now graphically, what did we just find? And this graph is, this is a parabola also. And let's see. Our function was 2t squared minus t. And I'm going to factor out a t, so I get 2t minus 1. So you could find the vertex. There's all kinds of ways that we can graph a parabola. But I'm going to do it by intercept. So I know it's got an intercept at 0, right? The zeros. And this is 0 and t is 1/2. So I'm going to not necessarily draw it to scale just because my scale needs to be pretty small, because I'm finding between 2 and 5. So my parabola is going to come, it has to come through there, and then it goes on. Whoops, pretend that that's an isometric parabola. So when I'm going from 2 to 5, again, this is not to scale. So what we're finding is the average rate of change of the function in this little area. So you're doing the change in y over the change in x, right? So this change in y is the net change. The change in y, which is y2 minus y1, which in terms of this, it will be f of b minus f of a. And then the change in x is your, in this case, 5 minus 2, which is 3, or your b minus a. So that is what you're doing. So when you're finding the average rate of change of the function, you're asking how are the y values changing as the x changes. So it's really the slope of the line that would connect these 2 points. And so that's why it looks like rise over run, because you're really finding the slope of something. In my next video, we'll do just practice with some more examples of these. So I'm just going to call the video part 2 of section 2.4.